Yeah, hello student. Let's try to study the haloarene. The study of haloarene. Students, what we can do here if you talk about the haloarenes. So first one, let us try to understand the preparation. Right. So how can you do the preparation, student? The easiest method is from benzene. You can prepare the haloarene from benzene. How can you do, student? From benzene you need the dark reaction, student. Dark reaction, because the light reaction, that is, it gives the substitution reaction. So this is the benzene. You treat with the Cl2, student, in the presence of FeCl3, and this you have to take the dark, student. So it is going, the Cl will be added and HCl, so it will give the substitution reaction, but it should be the dark reaction, students. Okay, now what we have to do, let us try to understand the another one. Now, from diazonium chloride. So, from diazonium chloride, it is the name reaction, student. Diazonium chloride. And this diazonium chloride is named reaction, that is called Sand-Meyer reaction. Sand-Meyer reaction. Sand-Meyer reaction, if you see, student, Sand-Meyer reaction. So, first of all, we do the diazotization. This is the aniline, student. And if you are treating with the NaNO2 plus HCl 0 to 5 degree C. So what it is going to give? It is going to give benzene diazonium chloride N2Cl. And now you can, from here you can do the two reaction, student. CuCl, yeah, Cu2Cl2 plus HCl. So it will give the chlorobenzene Cl. You can take the Cu2Br2 plus HBr. So what is it? You are going to get the bromobenzene. Another is there from Gattermann reaction. From Gattermann reaction. Gattermann reaction is extension of the Sand-Meyer reaction only. You need to take the diazonium chloride only, student. This is the diazonium chloride. And in this diazonium chloride, what you need to do two things you need to do. Copper powder you have to take plus HCl. So it will give directly, it is going to give chlorobenzene. Or you can say copper powder you can take and then you take HBr. So this is going to give bromobenzene. This is the Br. So this is the method of preparation, student. Right. So three methods of preparation are there. Let us go for the chemical properties. Chemical properties of haloarenes. What is the chemical properties of haloarenes, students? What you are going to get from here? So let us do the short form of the reaction. First of all, this they do not give the substitution reaction, student, because of the presence of partial double bond character. They do not give the substitution reaction. Okay, then what you can do, student? First one, you can do halogenation, AlCl3, AlCl3. So this is going to give the para dichlorobenzene, student, or you can say 1,4-dichlorobenzene. If you take the another reagent, student, conc-HNO3, you can take conc-HNO3 plus conc-H2SO4. So what it is going to give, student? They are going to give the chloronitrobenzene. So Cl here, it can give the NO2 here, right? This is the. Now you can do the sulfonation, student. You can treat with the concentrated H2SO4, student. So if you are treating with the concentrated H2SO4, so here Cl and downside SO3H, this is there, student. Now Friedel-Crafts alkylation. Friedel-Crafts alkylation. Alkylation. So if you are doing Friedel-Crafts alkylation, student, so what it is going to, here is a Cl and downside CH3. What you have to take, student? CH3Cl plus AlCl3 anhydrous. Another things you can take, student, acylation, Friedel-Crafts acylation. Acylation means what? CH3CuCl plus AlCl3. This is there. Now what you are going to get, student, here? So here is the Cl is there. Here is C double bond O and this is CH3. 4-chloroacetophenone. It is the 4-chloroacetophenone. So these are the going to be the product, student. That is the chemical properties of what you call, student, haloarenes. Another is there, replacement reaction is there, student. Replacement reaction. But replacement reaction, it is the highly elevated temperature, student. Suppose you are taking the chlorobenzene, here is there, student. So it required, if you are treating with the NaOH, student, so you have to take 623 Kelvin and 300 atm. So it will give what is going to give, student? It will replace by OH group, student. Secondary condition is H plus. Now, if there is a electron withdrawing group, student, here you see this is Cl, and if you have the NO2 group, suppose NO2 group is at para position, so reactivity increases, student. Electron withdrawing group increases the reactivity, so it is NaOH at 443 Kelvin, student. 443 Kelvin. H plus you need to take. So the temperature get reduced, student. At lower temperature it is started going to give. Here 423 are there, 443. The lastly you see, student, if the more number of OH group is there, suppose here is NO2 is there, right, student, one more NO2 is there, so the replacement become very easy, student. NOH you take and 368 Kelvin, student, and here is H plus. So it is the very low temperature it is going to give is replacement reaction, student. This is the replacement reaction. Now what we are going to do, student, now we are dealing the, if the three group are there, okay, here is this is NO2, here is NO2, here is again NO2. So what you need to do, student, you deal with the NOH, just you need to warm, student. Here is Cl, sorry, this is Cl. Just if you are warming this itself, if you are warming this one, so itself it is going to what? Convert to give, that is OH, it will convert here. This is the NO2, here is NO2, this is the NO2, right? So these are the replacement reaction, student, and other reaction I already discussed with you. Two more reactions are there, student. Reaction with metal, reaction with metals. So how to deal with the reaction with metal, student? So one reaction is called Woods fitting reaction. Fitting reaction. Woods fitting reaction. A Woods fitting reaction. Woods means what? You have to take the CH3Cl. Fitting means what? You have to take, student. One you have to take the chlorobenzene. Okay. So that is what. So this is the suppose chlorobenzene you are treating. Okay. You can take the sodium, student. Here is the sodium required, 2 sodium. So what it is going to, this all is going to replace, student. So minus 2 NaCl is out, and here is what is methyl benzene it is going to give. Now another is there, student. This is called fitting reaction. This is the fitting reaction. For the fitting reaction, student, what you need to do, you take the two molecule of the chlorobenzene, right, and treat with the 2Na, student. So what is going to happen, this one, this is out, so this is going to give, student, biphenyl, right? This is the biphenyl and plus 2NaCl, this is there, student. So these are the all the chemical properties of haloarenes along with the method of preparation, student. Thank you very much for watching.